Hello, everyone. Wow, what an audience. Thank you, Jón Atli, for the kind introduction. I'm extremely honored to be here today on behalf of Marel to talk to you about future food production, what challenges it is that we are faced with, and which technologies we will need in order to meet those challenges. Now today, there are 7.7 billion people living on this planet. Population growth estimates project that by the year 2050, we will have grown to 9.7 billion people. And it is based on these facts that so many talks of our current day begin. But it isn't without a good reason. This increase of 2 billion people puts immense strain on us as a society. We have huge challenges in front of us, like climate change and limited natural resources. But perhaps the most challenging fact is to figure out how we can sustainably feed everyone with safe and nutritious food. Now, many of you might think that we simply cannot produce enough food for everyone. But it is, however, a fact that farmers, through agriculture and fishing, are capable of producing enough food for almost 12 billion people. So what's the real problem here? And the problem lies in food waste. It is estimated that annually 30 to 40% of all food being produced goes to waste or is lost in the value chain. And of course, there are immense resources that go into producing this food that never even gets consumed. And the value chain for food is quite complex. And a bulk of this waste takes place with the consumer and in our homes. But there is, however, a part of the value chain where companies like Marel can directly impact minimizing loss. And that is in the processing stage. Marel and companies alike provide processing solutions to the food industry. And it is therefore our responsibility to make sure that we develop solutions that pay the food produce with the highest respect and minimize the amount of waste that takes place in this part of the value chain. Now, one of the main themes of the conference this year is the automatic future. So I want to use the opportunity to talk to you about how automation will play a key role when it comes to minimizing food waste. Automation, as all of us know, is a clever combination of different technologies in order to perform a task with minimal human intervention. That is why automation can be the key solution in order to give the food industry with reliable and repeatable processing ways. By optimization of systems and parameters, we can reach a stage where we have increased yield and efficiency. Automation has, of course, been this huge promise of Industry 4.0, with hype such as smart factories and artificial intelligence. Automation has even completely disrupted so many manufacturing industries. And probably the best example is the automotive industry. This is what the manufacturing floor of a typical car producer might well look like. You have dozens and dozens of robots collaborating together in order to assemble individual pieces and parts to create a fully made car. Now, this is extremely impressive. So I ask myself, why not the food industry? Why isn't the food processor's plant filled with robots? Now, of course, don't get me wrong. There's a very high level of automation in the food industry. But there are still so many tasks that cannot be performed other than manually. In order for you to get a glimpse into why, I want to give you an analogy. Now, it's quite realistic that this car manufacturer is capable of rolling out one car every minute from its processing floors. This insane throughput is achievable due to automation and the optimization of the processes. But now consider that this same car manufacturer is required to roll out a car every minute where each and every single car just slightly varies from the one previous. It is here that this static automation model completely breaks. And this is the reality of the food industry. Food varies to such an extensive extent. Consider, for example, a carrot. It deviates so much in color, in size, and shape. When talking specifically about the protein industry, food industry is working with things like beef, fish, and even poultry. The anatomical differences of these species is extreme, and even just the interspecies variation is quite challenging. Take the example of, for example, whitefish. In the catch of the day, you can have a fish that weighs several hundreds of grams to several kilos. But on top of that, consumers are always pushing for more options and selections when it comes to their dietary intake. That is why food industry has this double-sided challenge. You have the extremely varying product coming in, and you need to be able to deliver an extremely flexible product going out. In order for us to create automation solutions with machines, our machines need to become intelligent. They need to be able to determine the parameters and variability of the food produce in order to optimize how they are processed. Now, machine intelligence is better known as artificial intelligence. And I want to show you a few of the techniques that we at Marel have put our recent focus on when developing the future solutions for the food industry. Now, I really like a statement that was made by Fei Li. She is a lead AI scientist at Stanford University. And she says, if we want machines to think, we need to teach them how to see. And I couldn't agree more. Vision is one of the most powerful senses that we as humans are equipped with. It gives us so much information to be able to interpret what it is that is in our surroundings. If we want machines to evaluate product variability, we need to equip them with vision. The human eye has had millions of years to evolve, and it is optimized to be sensitive to the red and green and blue light in our surroundings. It is then, through the processing of our brain, that we essentially see all of the colors in our environment. And this is exactly what commercial cameras are based on. It is the technology that you have in all of your smartphones. But camera technology, it isn't just limited to visible light. And it is through the development of semiconductors and scintillators that we can actually measure things like X-rays, infrared, and even ultraviolet light. Now, it doesn't maybe seem that amazing. Perhaps some of you had an X-ray image. But this image is actually interpreting something that is completely invisible to us. And this has, of course, been around for some time, but mainly being based in research institutes and in the medical field. It is only through recent technological advancements that these techniques have become robust enough and reliable enough to actually apply them in an industrial setting. At Marel, we apply different vision technologies to equip our machines with vision. Of course, one of them being X-rays. With X-rays, we can measure the density variations throughout a product. This makes us capable of determining whether the product contains contaminants that can potentially be hazardous. We also do something called 3D imaging. And through the clever combination of light and cameras, we can start to measure the exact surface geometry and the shape of a product. This information gives us the means to be able to estimate things like weight and volume. We even apply conventional color imaging in order to be able to determine things such as quality defects. Now, given information on these parameters of the product, we have reached the stage where we can start to actually make intelligent decisions based on these parameters of how to process the food. But some of these tasks are very trivial for a machine vision to do. The best example is probably here. Given a well-calibrated 3D imaging system and an accurate mathematical model, we can determine the weight of a fish to the accuracy of grams. This, however, would be an extremely daunting task for someone like me to do, with the throughput of several fillets per minute and an 8-hour shift. On the contrary, there are some tasks so trivial and so fundamental to us as humans that we almost cannot mimic them with a machine vision system. And this is the example of quality defect detection. Now, I'm quite confident that all of you here could highlight the regions in this fish that deviate in color. And as such, we are excellent at doing this deviation detection. We have evolved in this way through pure necessity of survival, because deviations in our surroundings can be potential threats to us. But finding a single accurate mathematical model in order to be able to describe this color defect and any other quality defect present in the product is almost not achievable. But luckily for us, there has been a huge leap within artificial intelligence, known as deep learning. Deep learning is this breakthrough technology that has almost gone completely under the radar for the non-tech savvy person. You being participants at a technical conference, I'm quite sure many of you have heard about deep learning, and some of you might even been working with it. But I can almost guarantee that each and every one of you has used it in recent times. Deep learning is the fundamental technology that drives applications such as Google search based on images. I could, for example, take a room, like here, photograph it, upload it to Google Images, and Google would probably be able to tell me that I am located in Eldborg in Harpa. Such is the power of deep learning. It can be able to interpret the context from just a single image. Now, when working specifically with image data, deep learning is better known as convolutional neural networks. This is quite a mouthful, but the key word here is neural. What we are trying to achieve when working with convnets is to mimic the fundamental workings of our brain. Scientists believe that when analyzing the visual input from our eyes, the brain first processes low-level features in what it is that we are seeing. It is then, through the complicated combination of the firing of the neurons in our brain, that we can start to process more and more abstract information from these low-level features. And that is exactly what a neural network is trying to do. In the initial stages of the network, it is trying to teach itself low-level features that are common for so many different things. These features are very simple and are, for example, an edge or a curve or even a blob. By then pooling together information of these low-level features, the network can start to teach itself more abstract information of larger image regions, like, for example, what is an eye or what is a nose. Going even deeper into the network, it can start to teach itself the differences of what is a face or what is a car. And it is the power of deep learning that has brought us so many different applications. The best known is image recognition. And this is what Google image search is based on, to be able to determine what an image contains. Taking it a step further, we can even do more sophisticated things, such as identifying different objects in the same scene. And this is one of the fundamental sensory inputs for self-driving cars. They need to be able to determine what are pedestrians and what is road. We have even seen applications known as image segmentation. Here, we're trying to partition an image into individual regions representing different objects. And this might well be the technology that drives the beautifying filters for your selfies. So, with the sophistication of deep learning, we have actually gone from the reality of 2012 and up until today. Not that many years ago, if you would have asked a group of engineers to take a photo and determine the location of where the photo was taken, it would have been quite simple. We have the advanced technology of GPS, and we can do a simple database lookup. But asking that same group to be able to determine whether that image contained a bird or not would have been a completely different story. This today is almost as trivial as just importing a library. But the networks will never become more powerful than based on the data that we train it with. And it is us that feed the bias into what the end result becomes. And I want to tell you a fun story about how deep learning can go completely wrong. There was a research group that had the task of making a model capable of determining different types of animals in images. It was extremely good at finding cats and elephants and dogs, but for some reason, it was amazing at finding horses in images. The scientists were really complex because, a horse is not any less complex than the other animals, so what's happening here? When looking at their data set, they realized that each and every single image of a horse had been downloaded from the same web page, and the logo of that web page was printed on every single image. So essentially, this network was good at finding cats and dogs and elephants, amazing at finding this logo, but had no idea what an actual horse looks like. But it is with the power of deep learning and us becoming the masters of our own application and supplying the correct data that brings us to the stage where we can do things like quality defect detection in food products. We can even do sophisticated things like determining a cutting pattern of a fish species that our systems have never even seen before. Now, machine vision and deep learning only takes us so far. And it isn't until we perform an actual action that we can say we have automated this process. And here is where robotics come to play. At Marel, we are working with sophisticated robotics like three-jointed arms. But we also work with much simpler mechanics, such as the swing of a knife or turning on a water jet nozzle. But it is based on this fact that we are no longer doing these actions based on a timed event, but a clever, intelligent decision-making that powers our systems to become smart. In order for you to get a glimpse of the actual solutions we are developing based on these fundamental technological building blocks, I want to show you a few examples. First is a system that does automatic cutting. Here, we apply machine vision by X-ray imaging, where we can determine quite accurately the location of the bones in, for example, a fish. Also knowing the thickness variation, we can apply deep learning to optimize a cutting pattern, making sure that we can completely remove the bones and making the product safe for the end consumer, but always striving for minimizing the amount of product that goes to loss through the system. It is then by applying water jets that we can accurately cut according to this predetermined pattern. Another system is a food inspection system. Now this one also uses X-rays, and it can scan through the entire food product, being capable of determining whether there's a hazardous contaminant. It is then through mathematical modeling that we can determine what type of contaminant this actually was. Was it a bone or was it a metal? We can cut around the contaminant accordingly, and we can steer our process, because metals are something that are not supposed to be in the food product and are completely a no-no in the food industry. Then, by rework, we can minimize the amount of food product that actually goes to an operator in order to have further inspection, and thereby minimizing the risk of potentially some of the product going to waste. The final system is an automatic batching system. Here, we use 3D imaging to determine the accurate weight and volume and precise location on the transportation belt of the product. Through optimization, we can then steer robotic grippers to pick up individual pieces and pack them together in trays. Now, these solutions wouldn't come without the power of artificial intelligence. And it takes the collaboration of such highly skilled experts to be able to achieve this goal. I'm really proud to say that most of the technologies I've presented today have been developed locally here in Iceland. One of my biggest fears when going from academia until the industry was to lose the connection with cutting-edge and state-of-the-art technology. That is why I am completely mind-blown every day when I come to work to see the innovative solutions my colleagues can come up with based on state-of-the-art technologies. But what will the future bring? As technology advances, we will see more and more sophisticated automation solutions in the food industry. We will reach a point where we have significantly reduced the amount of food going to loss, and perhaps even completely eliminated it. I'm also confident that technology will become the answer in solving food loss in every single other part of the value chain. Thank you.